Okay, this is mechanics, still on constant acceleration. Hi everyone. Let's look at this question here. A train running at 20 meters per second is brought steadily to rest in 2.5 minutes. Find the distance covered by the train in coming to rest. As I mentioned to you earlier on, these problems are normally straightforward, depending, you know, the formula to use. You got 5 different formulas, and you got to know which one is best for the question you are given to. For example, here you are asked to find the distance. Let's look at the formulas for distance under constant acceleration. You have one that says distance s is equals the initial velocity plus final velocity all over 2 times time. You have another one that says s equals the initial velocity times the time plus half times acceleration plus half times acceleration time squared. And you have another one that says s equals final velocity times time minus half times acceleration times time squared. They look similar, yeah? This is initial velocity, this is final velocity. So this is minus, this is plus. The rest is the same. And you have another one that says final velocity, the square of final velocity is equals to the square of the initial velocity plus 2 times the acceleration times the distance. Because from here, you can make s the subject of the formula, and you can still calculate your distance from this formula here. S, there is an s is the distance. That's what's given. S is distance, represents under these constant acceleration problems. So now you look at the problem you have. But these equations, as I said before, they are not included in the formula book. When you go to the examination or hall, they give you a formula book. There's lots of formulas there for you to see. They don't expect you to memorize all the formulas. But this, under this constant acceleration, because these problems are simple, so they decide not to give you the formulas. You memorize the formula, but if you solve this problem over and over again, these formulas will stay. They will stay in your head. See, but if find another means of memorizing them, if you cannot practice a lot of problems. But this is it. Now let's look at what we have from the question. They said a train is running at 20 meters per second. So which means this train's initial velocity is 20 meters per second. And is brought to rest steadily, is brought steadily to rest in 2.5 minutes. So the time is 2.5 minutes. And then they say find the distance, find s. It's s we don't know. So now these formulas are available to you. Which formula do you use? You can see that this is not suitable. This has v, you are looking for t. You are looking for, you have u, you don't have v. So this is, you don't have v, you don't have s. So you can't use this one, 2 unknowns. You can't use this one either. This one here, you have u, you have t. Well, you don't have the acceleration and you don't have the distance, so you cannot use this one. You have two unknowns in one equation, you can't use it. This one here, you have u, you have the time, v is not given, but from the equation, v is known. because they said it's steadily, it's brought to rest steadily. They don't give us the final velocity. It means the final velocity is 0. When it comes to rest, the final velocity is 0. So this is u plus 0 all over 2 times t. So this is what we use for this problem. Now, you can see here is minutes. Here we have seconds. They don't work together. We have to convert one to the other. Either way, you can convert this to kilometers per hour, and you convert this again to hours, and then you give your answer. But preferably, you convert this to seconds, and you got the equation 20 meters per second. So you can convert these minutes to seconds, then you can easily solve the problem now. You can't solve these two together. The units are not, they don't match. So what is 2.5 minutes to seconds? Convert it to seconds. 2 minutes. 1 minute is 60 seconds. So 2 minutes is 120 plus half minute, 30 seconds. So this one equates to 150 seconds. Or you can simply do, this is 5 all over 2 times 60. Think so? Convert into a minute. That's yes. 2 times 6 all over 2. Okay? Convert it to seconds anyway, because 150 seconds. So now you have your distance s equals the initial velocity, which is 20, plus the final velocity, which is 0, all divided by 2 times your time, 150 seconds. So this means you have 20 all over 2 times 150. Don't forget your unit will be, looking for distance. So your unit will be in meters. Yeah. So now you have 10 times 15, 150. So you get 1500. So this is what you get as meters. This is your unit. You are multiplying meters per second times second. Yeah, this is meters per second, means meters all over second times second. So this cancels. So what is left is m. That is the distance in meters. Thanks for watching. Bye bye.